Howdy y'all. In this video, I'm going to go work through exercise 6.8 from the Vaughn textbook using the truth table method. And in most cases, I'll be doing the abbreviated truth tables, so I won't be filling out the entire thing. All right, so here we're going to start. I just want to for those of you following along with the book, I just want to sort of mention that these are going to be a little bit scrambled as I'm going to start with the truth tables that only have 4 lines and they're kind of mixed in, and then move on to the truth tables with 8 lines. So remember, when there's only 2 sentence letters, there's only 4 possibilities, but when there are 3 sentence letters, there are 8 possibilities. And each time you add a sentence letter, you double the number of possibilities. But we're only going to look at arguments that have 2 and 3 sentence letters, so just 4 and 8-line truth tables. So remember, as we sort of go through this, each one of these, filling in the truth table is part of it, but the important thing is to state whether or not this argument is valid. So what we're looking for are situations in which the premises are true and the conclusion is false. And the abbreviated method allows you to sort of ignore situations as you're sort of filling things out where you have either a true conclusion or a false premise, because again, we're looking for all true premises and a false conclusion. So let's start here. The top left, this is the number 1 in the exercise. We just have one premise here and a conclusion, so not a whole lot to do here. The conclusion is just A, so calculating the value there is pretty straightforward because A is just A, so no calculation necessary. A and B require some calculations, so the ands are only true when they're both true but false otherwise. So that's going to be true up there at the top, but everywhere else you're going to have one or both of the conjuncts being false. So the whole sentence ends up being false in the other situations. So as a result, it's never the case that you have all true premises and a false conclusion, right? So the only time that you have, there's only one premise, so the only time you have a true premise, you also have a true conclusion. So it just never happens that you have true premise and a false conclusion. So that means the argument is valid. Bear in mind that it doesn't matter that you have a situation where everything is true. What matters is that you lack a situation where the premises are true and the conclusion is false. All right, so moving on, number 2 is P arrow Q, P therefore Q. This is modus ponens for anyone paying attention. And so we already know that this argument is valid. But just to show that that's the case, P arrow Q, the arrow rule tells us that it's only true when its antecedent is true and the consequent is false. So true arrow false. So that means it's going to be true here, false here, right? That's the one time you get true arrow false, and true here and here. The second premise is just P, so nothing to calculate there. Just restate the column, and the conclusion is just Q. So again, just the Q column, no computation necessary. All right, so this is valid. That's because there doesn't exist any line where you have all true premises and a false conclusion, right? You have all true premises, but the only time that happens, you also have a true conclusion. So no all true premises and a false conclusion, so the argument is valid. All right, number 3. Here's P or Q, P therefore not Q. This might look a little bit like disjunctive syllogism, but it isn't. And it turns out this argument is invalid. So let's fill out the table here. P or Q The OR rule is that it's usually true except when both the disjuncts are true, so you need false or false to make it false. And that happens down here at the bottom, but doesn't happen anywhere else. P is just P, so nothing too tricky there. And not Q is just the opposite of Q, right? So if Q is true, then not Q is false. And if Q is false, not Q is true. So we go from true, false to false, true, false, true. And as I mentioned, this argument is invalid, and that is because there exists a line where you have all true premises and a false conclusion. So this argument is invalid. Okay, moving on to number 4, P arrow Q. They're not P, therefore Q. We have the arrow rule here, so the only time it's false is when it's true, arrow, false. That happens in line 2, but nowhere else. Not P is just the opposite of P, so we go from true, true, false, false to false, false, true, true. And then Q is just Q, right? So nothing changes over here for Q. Just got to do your replacement. And so is this argument valid or not? Well, that depends on whether or not you have all true premises and a false conclusion. And we do, so the argument is invalid. All right, number 5. We've got A's and B's now instead of P's and Q's. A and B. A's are, remember, conjunctions are only true when both conjuncts are true, so that happens in line 1, but it doesn't happen anywhere else, so false, false, false. Not A is the opposite of A, so we go from true, true, false, false to false, false, true, true. And B is just B, so nothing changes there. So is it the case that we ever have all true premises and a false conclusion? No, right? In fact, it's never the case that you have all true premises. So these premises are sort of inconsistent. So you never have that line with all true premises and a false conclusion, and so the argument is valid. And that was number 5. Okay, so now we're skipping around here a little bit. So I'm skipping to number 10. Is the next argument that only has 2 sentence letters. We have P arrow Q and then P arrow P and Q. So a little bit more difficult of a sentence here. So let's start with the premise. There's just one premise. The premise is P arrow Q, so that is only false when it's true, arrow, false. So it's going to be true here, false here, true here, and true here. So that's what that looks like. And then P arrow P and Q, again, is the main connective here is the arrow, but we have to do this stuff in the parentheses first. So just show you the intermediary step here. So it's going to be true, arrow, true and true, which is true. Then it's going to be true, arrow, true and false, which is false. Then it's going to be false, arrow, false and true, which is false. And then it's going to be false, arrow, false and false, which is false. So you got to do that. Parentheses work first, right? That's the order of operations for you, before you can do the final calculation. But again, it's the arrow rule, so if you have true, arrow, false, it'll be false, but otherwise it'll be true. So it's the same, right? The truth table is the same here. So if the premises are true, the conclusion is always true. So you never have true premises and a false conclusion, so the argument is valid. All right. Okay, moving on to the next and final argument that has only 2 sentence letters, which is number 13. We've got Kind of a complicated first premise here. Our second premise is just P and Q, and our conclusion is P or Q. So if you'll notice that our first premise is kind of made up of the other sentences here, so maybe it'll help just to do the other sentences first. So second premise is a conjunction, right? Those are only true when both the conjuncts are true, otherwise they're false. The conclusion is a, the conclusion is a disjunction, and those are usually always true except when both of the disjuncts are false. So that's what that looks like. So where we're at now, we can actually sort of say something about the validity of this argument. We don't actually have to calculate the value of this. Because if you'll note, the conclusion is almost always true in in lines 1, 2, 3, and 4, but it is false in lines 4. But the premise is also false in line 4. So this is we can already tell that this that this argument is never going to have a line that has all true premises and a false conclusion. This is the abbreviated method. The abbreviated method tells you that you can ignore any line that has a true conclusion, like lines 1 through and 3, and then any line that has a false premise, like line 4. And so that eliminates all the possibilities, right? There's no line which has all true premises and a false conclusion. So we know, even without doing premise 1, that this argument is valid. Although I should sort of say that if you were to do sort of premise 1, bear in mind that you would do the work inside the parentheses first before you do that arrow. So for instance, line 2 would be true, arrow, false, right? Because P and Q would be false and P or Q would be true, but then the final value would be false because true, arrow, false is false. All right, so moving on. We're going to go back here to number 6, so jumping around a little bit. So number 6 is our first argument that has 3 sentence letters instead of just 4, instead of just 2, so that means we have 8 possibilities instead of just 4, and so the computations become doubled. So we're going to start here. I'm going to start here with Q just to kind of narrow things down a little bit. So remember that the only lines that we need to sort of pay attention to are the ones that have either sort of a false premise or a true conclusion, so I can ignore anything with a true conclusion, and that's going to be lines 1 and 2 and 5 and 6. So the only time I get a false conclusion is 3 and 4 and 7 and 8. So I'm just going to look at these 4 lines right now, and then if any of these turn out to be, if the premises of these turn out to be all true, then I'll be done. So I'm going to just go here just to kind of speed things up here a little bit. I'm just going to do the bottom row because it looks to me that I'm going to get all trues if I do this. So I'm going to end up with, here, I'll show you the intermediary step here. P's are false and the Q is false, so I'm going to have false, arrow, false. And R's are false too, so false, arrow, false again. And remember, with arrows, the only time arrows are false is if it's true arrow false, right? If the antecedent is true and the consequent is false. So both of these are going to turn out to be true. So true premises, false conclusion. The argument is invalid. You don't need to fill in any more of this truth table if you get to this point. Okay, moving on. This is number 7, bottom left here. Once again, we've got 3 sentence letters, so we have 8 possibilities, but I don't want to look at everything, so we're going to start with the conclusion here. The only time the conclusion is false is, oops, hold on a second. The only time the conclusion is false is and the even numbers, so 2, 4, 6, and 8, I get a false conclusion, and then I can do this work over here. So P arrow Q, remember, is only false when it's true arrow false, so it's going to be true here, false here, true here in the bottom, and then Q, excuse me, not Q and R, is a conjunction, so that's only true when both the conjuncts are true. So I need to have Q be false and R be true in order for that to work, because we do the negation first in this instance. So Q is false and R is true right here. So that will get me sort of a true premise. Otherwise, the premises will end up being false. But that's it, I guess. So there's no line, right, that has all true premises and a false conclusion. So that means this argument is valid. All right, moving on to number 8. Yeah, 8. We've got our letters have shifted to A, B, and C now instead of P, Q, and R, but same kind of deal. If the premises are true and the conclusion is false, the argument is invalid. So again, I'm going to kind of do the abbreviated method here, looking at the conclusion. I see that the only time the conclusion is false is down here at the bottom. So don't need to pay attention to what's going on at the top. Then I have A or B and C. So I got to do the work inside the parentheses first. And so A needs to be either the case that what's in the parentheses needs to be true, or A needs to be true. But it looks like that's only going to happen right here. Everywhere else, either both A is false and B and C is false, and so the whole thing ends up being false. So I'm left with just this one line then as being the possible line. So I'm going to have to do this calculation here. So it's going to be not the case that true and true, and you do the parentheses first, so it's going to be not the case that true. So that ends up being false. So what we're left with then is a valid argument that it is not possible for these premises to be true, and the conclusion false at the same time. All right, on to number 9. So here we have, again, just sort of a switch in numbers. Instead of P, Q, and R, we have X, Y, and Z. This is, if you sort of notice, hypothetical syllogism, X arrow Y, Y arrow Z, therefore X arrow Z. So this is from chapter 3, a form that we know is valid, but this will be a demonstration of such. So not a whole lot of narrowing things down here, with the exception of the conclusion. So arrows are usually true. The only time that they're false is when you have true arrow false. So you would need X to be true and Z to be false, and that happens here, and it happens here. So just 2 lines where that happens, and so we're down to just these 2 lines. So if it ever turns out that these premises are both true, the argument will be invalid, but it's not going to happen. So true arrow true is true, but true arrow false is not. And true arrow false here, even though false arrow false here. So it just doesn't happen, right? So either the conclusion is true, or you have a false premise, and that eliminates all the lines. So that means this argument is valid. So hypothetical syllogism is a valid argument. All right, number 11 is A arrow B, B arrow C, B and C, or A and B. Kind of a mouthful here, but again, this is, if we start with the premises, these are fairly simple calculations. So remember, arrows are only false when it's true arrow false, and with A arrow B, that only happens in 3 and 4. And with B arrow C, that happens in 2 and 6. So that actually does eliminate a number of possibilities. So we're down to, here I'll show you which ones we eliminate here. So we've eliminated 1 and 2 and 3 and 6, right? So we could ignore any of these that have false premises. So if, with this conclusion, if any of these turn out to be false, then the whole thing will be invalid. So it doesn't happen up here. So here we have, you got to do the work in the parentheses. So we end up with true or true, which is true. Here we end up with, let's see, B and C is false, no, is true, or true or false. A and B is false, so that's still true. But down here, it looks like we're going to get false or false. So A and B is false, B and C is false, so false or false is false. It also happens down here. So in both of these situations, you have true premises and a false conclusion, but one is sufficient to show you that the argument is invalid. So there you have it. That was number 11 in the exercise. All right, number 12 is another A, B, and C situation. We have not A as our conclusion, and so I'm going to start there because that helps narrow things down, right? We have 4 falses and then 4 trues. So we just have to look at what's going on at the top. If not A, see if A is true over here, then whatever B arrow C is going to be is not going to matter. So it's going to be true arrow something, and that's true. So so far so good. And B and C, so you just got to get B and not C. So as long as B is true and C is false, you'll get true and true, and that'll happen here. So true premises, false conclusion, the argument is invalid. Okay, so moving on to the number 13, we have, number 14, sorry. Number 14 is P arrow Q, not the case that Q or R and not P. So again, I'm just going to start with the conclusion because right away I see that that narrows things down to just the top 4, so only the top 4 could possibly work here. P arrow Q is pretty easy calculation, so it's true, true, false, false, so see true, you get true arrow, false in both 3 and 4. And so that narrows things down to just 1 and 2 now. So again, you can ignore any line with a false premise. And so we just got to see if these turn out to be, if any of these turn out to be true. So here's a situation where you got to do what's in the parentheses. So you're going to have not the case that true and true, which is true, but not the case that true is false. You're going to have not the case that true or false, which is true, so not the case of false. So you end up eliminating everything, right? So no situation with all true premises and a false conclusion. So this argument is valid. Okay, so moving on to number 15 at the top left here. Number 15 is a little bit longer because there are 3 premises instead of only 2. So we're going to be on the lookout for true, 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 false. But that third premise is pretty simple. It's just E. So true, true, false, false, true, true, false, false. That eliminates half. As this is a premise, we don't need to look at 3 and 4, 7 and 8, just 1 and 2 and 5 and 6. So just a question of, well, can we have true premises and a false conclusion? It's not going to happen on the top here. Everything's going to be true. Let's see, D and F. Well, here's a false conclusion. E or F is true, and D arrow E is true. So that looks to be, let me just double check here. Yep, looks to be all true premises and a false conclusion. So that means the argument is invalid. Don't forget to say that part. So moving on to number 16, we've got another situation where we have 3 premises and 1 conclusion. So, figuring this out requires some work, but some of these are pretty easy. So the conclusion is just P. That narrows things down pretty quickly. So we're just looking at the bottom half now. So 5 through 8. The third premise is just not R, so that's going to narrow things down even more. So true, false becomes false, true, false, true. So we're left with just these 2. So we're going to have not the case that P arrow Q, which is a situation where you have to do the parentheses first and then you do the negation. So both of these are going to be not the case that false arrow, let's see, false arrow true, which is true. So not the case that that is false. And then not the case of false arrow false, which is true. So that is false too. So that means we're done, right? There's no there's not going to be a situation where you have all true premises and a false conclusion. So that means this argument is valid. So remember, you can ignore any line with a false, a false premise or a true conclusion. So in the first 3 lines we had, the first 4 lines we had a true conclusion, and then in the final 4 we had a false premise. So that eliminates everything, and that means the argument is valid. All right, number 17 is kind of interesting because the conclusion of this argument can never be false. So that's going to eliminate everything right away. So if you'll sort of notice here that in order to sort of calculate this conclusion, you need to do the premises, what's in the parentheses first. And the only way to make an arrow false is to have true arrow false. So you would have to have what's inside the parentheses true here and false here, but that can't happen. What's inside the parentheses in the antecedent is a conjunction. And conjunctions are almost always false, right? The only time that they're true is when both conjuncts are true, but making both conjuncts true, making D and E true, is going to make D or E true, right? Because D and E, true and true, is equivalent to D or E, true and true. So that it's just an impossible situation to achieve, right? So you can never get true, arrow, false here, and thus the conclusion is a tautology. The conclusion is always true. So this argument is valid. There's no situation where you'll have true premises and a false conclusion. Number 18 has D, E, and F again. So we have not the case of D and E, E or F, therefore not D and E. This is a situation where you got to be careful about sort of how you calculate things. So with the premise, you want to make sure you do the parentheses first and then negate that. But with the conclusion, you do the negation first. But the conclusion is going to be sort of false a lot. So let's just kind of see how this kind of plays out. So not D and E. I'm going to start with the conclusion here. So not D is going to end up being false in the first four. It'll be true in the last four. So if E is true in any places, then that'll be true. Okay, so you get true here, false everywhere else. E or F is true a lot, right? It's true unless they're both false. So that happens a couple times, right? They're both false in line 4, and they're both false in line 8. And then D, not the case at D and E. So D and E is going to be false a lot, but if you negate it, that'll end up being true. So D and E is going to be true in 1 and 2 and false in everywhere else. So it'll be not true, and then everywhere else it's going to be not false. So it'll be false up here, false, false, but it's going to end up being true everywhere else. So that should be enough to get you all true premises and a false conclusion somewhere, and yeah, it happens right here. So line 3 and and line 7, but it doesn't matter. But line 3 has all true premises and a false conclusion. So this argument is invalid. Okay, down to the final two here. So number 19 and number 20. Start with number 19. So the conclusion here is pretty straightforward. So you only have a false conclusion when F is false. When F is false, that makes this second premise true. So because you get false arrow something in all those cases. So false arrow true, false arrow false. Either way, it's going to end up being true. And then that leaves this scenario. So if this ends up being true in any of the situations, then we'll have an invalid argument. And it does happen in line 2, it looks like. So here we're going to have true and not true, arrow not true, which is going to be false arrow false. And false arrow false is true, so you end up with true and true. And that whole thing is true. So true premises, false conclusion. The argument is invalid. Okay, so final one here. We have D or not E. We have F arrow E. We've got D arrow not F. Let's see, D arrow E. That's going to be, D arrow not E. It's going to be true everywhere except for 5 and 6. F arrow E is going to be true as long as it's not true arrow false. So true, true, false, true, 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 false, true. And then D arrow not F is going to be true when it's true arrow false, or everywhere except where it's true arrow false. So you get true arrow false here, and that means you've got an invalid argument. So all true premises and a false conclusion. All right, so there we have it. All of exercise 6.8 from chapter 6 filled out. So I hope this helps.